Today we are going to start section 8.5. We are going to solve exponential equations. To do that, we are frequently going to be using logs. Here we go. For our notes, got some blanks to fill in. An equation of the form b to the cx equals a. I'll rewrite that in case it's a little hard to see. B to the cx equals a, so cx is our power, where the exponent includes a variable, is called an exponential equation. You can solve an exponential equation by taking the logarithm of the same base to each side of the equation. So we have the question, which base should you use and why? Anybody think of a base that we might want to use?
10.
Why base 10?
Because it's the one that's like the
It's the common one. It's also the one that your calculator uses. That's it. So the common log of base 10 is the one we would want to use. Why? So we can use a calculator. Your calculator functions in a base of 10 anyway. Okay, then let's practice doing some of this. Solve the following by taking the log of each side. So they even told us what our first step should be. We are going to take the log of each side. So log of 7 to the 3x equals log of 20. If we do something to one side of an equation, we have to do it to the other side. So that includes applying functions, a logarithm. Now, I can plug log of 20 straight into my calculator and get a number for it, but I cannot plug in log of 7 to the 3x. So before we go on, we need to apply one of our properties that we learned in 8.4, the power property, because that allows us to take the exponent of 3x and put it where? In the front. So now I have 3x times the log of 7 equals the log of 20. So we can't forget those rules that we learned before. Now our goal is going to be to get x by itself. If you want to, before you do that, if you think it'll help, you can go ahead and evaluate the log of 20 and the log of 7. Or we can go ahead and start trying to get x alone. What do you want to do? Okay. If I'm multiplying by the log of 7, how do I undo multiplication? Division. So I could divide both sides by log 7. Now, there is not a property that we can apply to this because they both have a log. Do we understand that? Do we see how that's different from before? If they both have a log, there's no magic property. We just have to calculate what that would be. So the log 7s cancel from the left. We're left with 3x equals. Now, if you are using your calculator, technically we could put this all in at one step. Now, remember, this does not work for any of our properties because they both have a log. So we can't simplify this before we type it in. So if you type this into your calculator all at one time, you have to type in log, it usually will open parentheses for you, 20. You have to close those parentheses, then hit your division button, log 7, close your parentheses. We all understand how this has to work? If you don't close your parentheses, especially after the 20, and you just keep typing, most calculators are going to mess that up. Okay, if you don't tell it, stop taking the log here, and then start taking another log again later, it's going to think to do it all at the same time, and it does not work out well. Okay, so if we do this in our calculators correctly, log 20, close parentheses, divided by log 7, close parentheses, enter. What do we get to like 4 or so decimal places? Beautiful. 1.5395. But is x alone yet?
No.
We still have to divide both sides by 3. So again, if I'm doing this in my calculator, I would just leave that number on my screen and press the division button right away. So it says A and S divided by. Type in a 3, enter. And what do we get for x? Okay. So I'm fine with 4 decimal places. So 5132. So that would be our answer for x on example 1. Let's bring up number 2. This one I think is actually a little bit easier because our variable does not have another number multiplied to it. So it'll save us a little bit at the end. First thing we have to do is take the log of and, okay, both sides. So log of 3 to the x equals log of 4. We did the same thing to both sides. Now we can use which property? The power property allows us to take our exponent and put it in front of its log. So we have x times log of 3 equals log of 4. Now to get x alone, we have to undo some multiplication. So we are going to use division. What are we going to divide by? Log 3. And at this point, you can just use your calculator. They are both base 10. So we can type into our calculator as long as we are being careful to close our parentheses. So log 4, close parentheses, divided by log 3, close parentheses. What do we get for x? 1.262. I prefer 4 decimal places, so I'm going to put 19. If we have to round it, it would round up to 2619. All right, are we ready to move on?
Yeah.
Practice some more? Okay. Do we want to go through it together, or do we want some time to try 3 on our own? Okay, try 3 on your own. If you get through 3 and you want to start on 4, you can, but we haven't done one quite like 4 yet. But you can go ahead and see about getting it set up. Get your first couple steps done at least. As promised, Charles, you can tell me how I'm setting up number 3. Well, before I do that, I need a log. So where do my logs go? Okay, so we take the log of both sides. I like that. And then you said move what? 2x in front of its log 6 using the power property. Ooh, okay, equals log 21. What's next?
Divide log 6. Or,
Yep, divide both sides by log 6. So that leaves me with 2x equals, and then I got to use my calculator carefully. Log 21, close parentheses, divided by log 6. What do we get? 1.6992 is what I got. Do we agree? All right, Charles, what's my last step? Divide both sides by 2. Divide by 2. What do we get? 0.8496. Beautiful. Anybody else get that?
Yeah.
A few of us did. Good job. Emily's going to help us through number 4. What am I going to do?
Make the
Log on both sides. Good. Okay, what next?
and then maybe x plus 4 in front of log 3.
Good. So I would maybe even put that exponent in parentheses because the whole thing is going to go in front of the log 3. So x plus 4 times log 3 equals log 101.
And then I divide that by log 3.
Good. Divide both sides by log 3.
And then
So what are we left with?
x plus 4 equals 4.2009.
2009. Let me double check that on my calculator just because that's where it seemed some people disagreed.
I agree.
I would agree with that. And then my last step is to
Subtract that 4.
subtract the 4, which is actually very nice on this one. We might not even need a calculator. What are we left with?
0.2009.
Oh, yeah.
0.2009.
Because I'm putting log 6 in my calculator.
Okay, then let's move on to number 5 and make it just a smidgen more interesting. Yes, this is 3 to the x here. 5 minus 3 to the x equals negative 40. Now, I'm not saying that you have to do it this way, but this is how I'm going to recommend doing it. If there are things you can do to start getting x alone before we take the logs, we should do that because that'll make our lives simpler.
What do you mean?
So what could I start doing that would get x a little bit more alone than it is right now?
Divide with 5.
Logan?
Minus my 5?
Minus that 5 from both sides. This is a positive 5. If I want it to go away, I would need to subtract it. If I do it to one side, do it to the other side. So we have negative 3 to the x equals negative 45. Now there's one other thing I would recommend doing.
Just
Divide, not a positive one, a negative 1. If I divide both sides by a negative 1, it's going to change both sides to be positive, and that just makes my life a little bit nicer. Are we okay with those first couple steps? Okay, now our life is going to be way simpler when we go to continue solving this using our logarithms. So now it's like the first few problems we did. What am I going to do on both sides? Log base 10 on both sides. And then? No.
We'll have to move the
Move our exponent out. Use that power property. So x comes out in front of the log 3. And now we're ready to divide by log 3 on both sides. Now, even though 45 is nicely divisible by 3, and you might be really tempted to do that, don't. They both have their own log. Just type it into your calculator like we were doing before. So log 45, close your parentheses, divide by log 3, and what do we get?
3.4645.
3.46.
So I would agree that this would end up rounding off at the 5 zeros. So 3.46497 If we use the 7 to round the 9, 9 goes up to a 10, which bumps this 4 up to a 5. So 3.4650. You might lose a point if your rounding is incorrect. Because then it would be like, well, you had a close answer, especially if you show me all your work. It's like all your work was right, your answer is just a little off. You could still lose a point. Questions, concerns? We're sure? Are we ready to talk about change of base formula? I guess. Okay, let's go to the back then. Change of base formula. You can evaluate a log of any base using the change of base formula. So remember before when I said we had to either switch it to exponential or our calculators can't do it because it's not a base 10. I believe I might have mentioned once that we would learn how to change them so we could use our calculator. Today is that day. Here it is. Ooh. For any positive numbers m, b, and c, with b and c not equal to 1, log base b of capital M is equal to log base c of capital M divided by log base c of b. B down here, meaning it came from the base over here. So this is telling us that we change it to some base. In my mind, I like to think that's why they use a C. That's the base we're changing it to, top and bottom. Okay, the M came from the number that we were taking the log of. The B was our original base. So, once again, which base do you think we want to change both of them to?
10.
10. Okay, so ideally, we'll always make C be a 10. We'll use log base 10 on both. I don't know that this part's necessarily in your notes, but it's good to give ourselves a reminder that having a base of 10 makes our lives a little bit nicer when we have a calculator. We ready to give this a try? Okay. Now, on these problems, they might look a little bit familiar, except they are problems that we wouldn't have been able to solve before. Now, before we knew change of base, if I asked you to evaluate, that was when we set this equal to what? X. And then we changed it to exponential form, right? So this is not what I'm going to recommend you do. This is not what I want you to do on these, but this is just showing you how we would have tried these before. We would have set it equal to X. We would have switched to exponential form, meaning we would have used a base of, no, what's our base here? 3, raised it to the X and set it equal to 15. Now I'm telling you we won't do that now because there's no way to rewrite 15 as some multiple or base of 3. Does that make sense? So this old way wouldn't work here. Luckily, today we learned change of base, so we can do this. So I'm going to have a log on top and bottom. I'm going to use a base of 10, so I'm not actually going to write my base. On the top, what am I going to be taking the log of? 15, and on the bottom, 3. What do you think we do next? What are you using to do the rest of this problem? A calculator. Grab your calculator. Type in log 15. Remember to close your parentheses. Divided by log 3 equals. We get 2.4650. Beautiful. Questions, concerns about number 6? All right. We're sure, because if I move on, it disappears. Okay. Number 7. I'm going to use my change of base. So on top, what am I going to have?
12.
Not just a 12.
Log 10.
Log base 10 of 12. And on the bottom,
Log base 10.
log base 10 of 6. And we use our calculator. 12, close parentheses, divide by log 6, enter. What do we get? 1.3869. I would agree with that. Which again, this is why we can't use exponential form, because these do not come out to rational numbers. These are big, long decimals that might not ever end. Other questions before we put up the last 2 for you to try? Okay. Take your silence as a no. All right, why don't you give these 2 a try, and we'll talk about them in just a couple minutes, since these go very, very quickly. And someone that I have not heard from yet today, tell me how they use change of base formula on number 8. Izzy?
Log of 4 divided by the log of 5.
Beautiful.
And you get 0.8614.
8614. Do we all agree with that? Okay, good. And somebody new to help me out with number 9. Caden?
Log 473 over log 12.
Log 473 over log 12. I agree. And we got
2.4786.
786. So, we're good on that one also. Questions, concerns? How are we feeling about today? Good? All right, ready for our homework?
Yeah. You need to take a quiz over.
All right, so homework should be up on Classroom, page 456, 1 through 17, all of them.